This video is part 2 of solving systems of equations using matrices. So in the last video we went through and we just solved this system using elimination. Now I'm going to show you how to solve this system by using matrices. So a matrix is just an array of numbers. So we need to first be able to set up the matrix from the given system of equations. In a matrix, we do not put the equal sign, but we put a vertical line. That vertical line designates the equal sign. Remember, a matrix is just an array of numbers. So all we're going to have in this matrix is numbers. The numbers are going to come from the coefficients of each of the variables. So we start off with the x. The coefficient to that, or the number in front of it, is 1. So in the spot for the matrix, we're going to put a 1. My next variable, again going across the equation, is y. So the coefficient, or the number in front of it, again is 1. So in that spot, I'm going to put a 1. Then I have my vertical line for the equal sign. And then the coefficient after the equal sign, or the number in front of the variable, which notice there is no variable, but the coefficient is still 1. So I go to my second equation. Again, all we're looking at are the coefficients. We're just plugging in the numbers into the matrix. So the coefficient in front of the x is 1. The coefficient in front of the y is -2. Do not forget those minus signs. You can change to plus and negative. That -2 makes a big difference. Then I have my vertical line for the equal sign. And then after the equal sign, I have a coefficient of 4. So this is the matrix that we have to have set up in order to solve this using matrices. So if you read the textbook, as seen here, this is a different problem. Notice the first thing you need to do is set up the matrix, which we already did. And then you need to use elementary row operations to write an equivalent matrix that looks similar to this. So there's a decent amount of math involved here to do. But even quicker than doing all this math, we can get a matrix to look like this by using a graphing calculator. So you will need a graphing calculator for this section if you do not want to do the math by hand. If you have an Android phone, this app Wabbit Emu will emulate exactly what you see on my screen here. You can also download this Wabbit Emu to your computer. You do have to download the TI-84 Plus off of Texas Instruments website first before you download the Wabbit Emu app. If you need help getting the Wabbit Emu onto your computer, go ahead and see me. If you don't have any access to a graphing calculator, again, please come and see me. I do have some extra that you can borrow to complete this section with. So we're going to complete this problem using the graphing calculator. Remember, the first thing, we have to set up our matrix, which we already did on a previous screen. So here is the matrix that I created already. So the first step we want to do is we want to type the matrix into our graphing calculator. So first thing, we're going to turn on our graphing calculator. And we want to go into the matrix menu. That would be, the matrix menu is located right above the x to the -1st button. But notice how matrix is in blue. So you have to hit second matrix in order to open the matrix menu. From here, this is all the stuff that you can deal with matrices. These are all the matrices that are in your calculator. The math is every possible thing you could do to a matrix. And then edit is where you will type in your matrix. So we're going to edit matrix A. So when you are entering a matrix into your calculator, you want to enter it row by column. So if we look at this matrix, there are 2 rows. So I'm going to hit 2 and then enter. And there are 1, 2, 3 columns. So again, I'm going to hit 3 and enter. And then I'm going to type in the values into the matrix. So 1 is the first entry I see. Notice my little black cursor, that's where it's highlighted. So I'm going to hit 1 and enter. The little black cursor does move across the row. So the next entry I'm going to enter is 1. So 1, enter. Again, the cursor keeps moving across the row. So 1, enter. And once you get to the end of the row, it goes to the next row. So I'm going to enter all of my values into my calculator. You can move your cursor up and down, left and right if you make a mistake in typing something in. Just type right over the value and hit enter, and it will it'll put the correct value you want in. All right, after this we want to quit out of my matrix menu. So we need to quit. Notice quit is above mode, but because quit is in blue, we're going to hit second mode to take me back to my home screen. So in order to solve a system of equations using matrices, we want to do something in the calculator called reduced row echelon form, which is abbreviated in the calculator as RREF. So we need to open our matrix menu again. So second, x to the negative first opens our matrix menu. The math menu in here has everything we could possibly do to a matrix. And we're looking for RREF, reduced row echelon form. Please realize there is an REF. You want RREF. That is reduced row echelon form. And we're going to choose it, and it puts it on your main screen. Now we need to tell the calculator which matrix we want to do this reduced row echelon form to. So we need to enter matrix A. So we need to go back into the matrix menu. And these are all the matrices we have stored already. So we want to choose matrix A because that's what we edited as this matrix. So to choose it, we're just going to hit enter. And we're going to close our parenthesis that designates we're only doing the reduced row echelon form to matrix A. We're going to hit enter one more time, and it gives us a new matrix. So we get a new matrix of, again, reading across the row, 1, 0, 2, 0, 1, negative 1. Notice the calculator does not put the vertical line in, but we know the vertical line is before the last column. So I'm just going to put that in manually. Now we take these numbers, these coefficients, and we're just going to rewrite my system of equations, but with these new coefficients. So the coefficient in front of this first x now is a 1. So I have 1x plus. My new coefficient in front of the y is 0. So I have 0y. My vertical line means equal, and I know it's equal to 2. So I'm rewriting my system of equations based on this matrix. So my second equation, there's a 0 in front of the x. Then I have a plus 1y equals negative 1. So here's my new system of equations. When you look at this, we know there's no y here, so we can kind of ignore that, and we know there's no x here, so we can ignore that. So now we know 1x is equal to 2, which is the same thing as saying x equals 2. And now we know 1y equals negative 1, which is the same thing as saying y equals -1. But don't forget, just because we have our answer like this doesn't mean it's completely correct. This is an ordered pair in which x is 2 and y is -1, which, if you remember from the last video, was the same answer we got.